This is the Module 9 review for Algebra Honors for you to watch after you've completed the review in class and hopefully answer any questions you have before the test. The first questions asked us which system could be solved with the elimination method using addition, which means we're looking for the pair of equations that when added together, one of the variables would eliminate. So if we look at choice A, if I were to add these two equations together, even though the x's have the same coefficient in front of them, since they're both positive, adding them wouldn't eliminate them, and adding the two equations wouldn't eliminate the y's either. So A is not the correct choice. Choice B, 11x plus 8x, that doesn't cancel, and neither does 7y plus negative 4y. So choice B is not it either. Choice C, 11x plus x would be 12x. Negative 7 plus 4y would not cancel either. So that means choice C is not it. So that should leave us with choice D, but let's make sure. Choice D, if I add those together, the 11x's, since one's positive and one's negative, those would eliminate. They would cancel out, which means choice D is the correct answer. This question is similar to the first one, but it's asking for which one would require the most work before solving it by applying the elimination method. So if I look at choice A, well, choice A, all I would have to do is multiply the bottom equation by negative 1, because then the y's would eliminate, so that's not that much work. Choice B is the same amount of work, because if I multiplied the bottom by negative 1, the x's would cancel. Choice C, it looks like I would have to multiply both of the equations by a number in order to make a match, but I'd only have to multiply by positives because they're already opposite signs. So C looks like the most work so far, but let's see what we have to do for D. D, I would have to multiply again one of the equations by negative 1 to make your 12y's match and become opposites. Be careful here because they did flip the order of these. So you want to make sure you're thinking of your y's eliminating and your x's. You can also simply multiply this one by 8 in order to make the x's cancel. So C is the only one that you would have to multiply both equations by a number. So C would be the one that requires the most work. Here is a multiple response question, which means you could have one answer, two answers, three answers, four answers, or five. You have to make sure you check all of them before saying you're done with the answers. So we know that our solution to the system is negative 3, 4. And we want to know if it's a solution to which of the following equations, which means if I were to substitute them in, the left side would become equal to the right side. So we're going to be plugging in negative 3 and 4 for each x and y. So let's start with A. A says x plus y, so that would be negative 3 plus 4 minus 2. And then in parentheses, x minus y, so that's going to be negative 3 minus 4. And I want to know, does it equal 1 minus 2 times negative 7? So let's start simplifying on the left here. Negative 3 plus 4 is 1. Before I multiply that negative 2, I'm going to go ahead and combine my terms in the parentheses. Negative 3 minus 4 is negative 7. Well, if you notice here, the equations are the exact same, which means the left side is for sure going to equal the right side without even doing more work, so A is it. Now, I can't just say A is the only answer because there could be more than one. So now we move on to B. 3 parenthesis x plus y, so that's going to be negative 3 plus 4 plus x minus y, and I want to know if that's equal to 3 times 1 minus 7. So simplifying the left side, Combining in the parentheses, that turns it to a 1. Plus -3 minus 4 makes a -7. Well, the left side already matches the right side, so that means B could also be correct. Let's look at choice C, which says x plus y, so -3 plus 4 plus 5, parenthesis, not x, what's x? X is -3 minus 4, and I want to know if that's going to equal 5 times 1 minus 7. On the left side, -3 plus 4 is 1, plus 5 times -7. That is not what the right side says, so I know C is not a solution. So now checking D, which says -4 times x plus y, so that's going to be again -3 plus 4, plus -3 minus 4, is that equal to 1 minus 4 times -7? Well, on the left side, we're going to be taking -4 times 1 when I simplify the parentheses, minus -3 minus 4, which is -7. That is not what the right side says, so D is not a solution. So last one, letter E. I'm going to do that over here. X plus y, -3 plus 4 minus -3. Be careful there. Make sure you don't just put -3 there. And then plus 4. And I want to know if that's equal to 1 plus 7. -3 plus 4, well, that's 1. Go ahead, add the opposite there. 3 plus 4 does make 7. So yes, E does make the left side equal to the right. So number 1, there are 3 answers to it, and since it's a multiple response, you do need to write all of them. And it is A, B, and E. Number 2 is asking for which system has no solutions. No solutions mean we're looking for our variables to cancel and the left side to not equal the right side. This is under the multiple response category, so we have to check all of them. So starting with A, we could substitute to solve this because y is by itself. So I'm going to take the second equation and insert y, which is x plus 2. Start simplifying. Which turns that into 2x plus 4 minus x. Now this x and this minus x are like terms, but 2x minus x is just 1x or x, which means this one would have a solution because the variable didn't cancel. So it's not A. So moving on to B. B is not set up right away for substitution. You could turn it into it. You could also line them up so that your x's and y's match. I'm going to go ahead and solve for y in the second equation since it's almost by itself. So I'm going to rewrite that second equation. And I'm going to add 2x to get that by itself. So now I have 2x minus 3 equals y. And I'm going to insert that into the top equation for where I see y. So we have 2 times y, so 2 times 2x minus 3 equals, plus 6. Equals 4x. So 2 times 2x is 4x, 2 times minus 3 is minus 6, bring down the rest of it, Well, minus 6 plus 6, those are going to cancel. I have 4x equals 4x, which is a true statement. So even though the variables would cancel here, it's a true statement, which means the answer would actually be infinitely many. And we want no solution. So choice B is not a choice either for no solution. Moving over to C. Well, looking at this, I can rewrite it so that the variables are lined up. So I'm going to rewrite that top equation and put the 2x first. And then it's actually lined up, even though the variables are on different sides, with the other one. Well, to make either the x's or the y's cancel, I'm going to multiply this one by negative 2. So that's negative 4x equals negative 2y minus 6. Well, the x's will eliminate, the y's will eliminate. So I have 0 on the left, and on the right I have a negative 9 when I add them together. That is not true, which means C has no solution. And our last one to check is D. D is set up for substitution since we know what the first y is. So I'm going to change the second equation, replacing that y, so it's going to be negative 2 equals. Instead of y, I'm going to put 2x minus 5, and then bring along the minus 2x. Well, 2x minus 2x will cancel. We're left with negative 2 equals negative 5. That's false as well, which means this one has two answers for no solutions, C and D. To tell whether negative 5 and negative 6 is a solution, we're simply going to plug them in for x and y, not just for the first equation, but also for the second. Because remember, it's a system, which means it has to be true for both. So plugging them into the first equation, instead of x, I'm going to put negative 5, minus 2, instead of y, it's negative 6. And I want to know if that's going to equal 7. Well, this becomes negative 5 plus 12. Negative 5 plus 12 is 7. So it is a solution for the first equation. But in order to be a true solution, it also has to be true for the second. This one starts with y, so we have to put negative 6 first, minus negative 5. I want to know if that's equal to negative 1. Well, here we add the opposite. Negative 6 plus 5 is negative 1. So since it's true for both, this is a solution. So yes. So here Julio wants to solve the system using elimination, and we want to know what's the best way to begin. Remember, with elimination there are multiple options, but we need to pick which is the best, which means the least amount of work. So the question is, do I make my x's match as opposites, or do I make my y's? Well, to make the x's match, I would need to multiply this top line by 8, because then I'd have a positive 8 and a negative 8. That's pretty simple. Looking at the y's just to make sure, the y's are opposites, but I can't turn a 9 into a 2 or a 2 into a 9 by multiplying, so I'd have to multiply the top and the bottom both by a constant. So since to make the y's eliminate, I'd have to multiply both equations, the best way is to eliminate the x's, and that's to multiply the first equation by 8 to eliminate the x's. Here's one of our word problems. We have Jake and Carla who are filling an aquarium tank, So Jake's holds 200 gallons. Carla holds 300. To be honest, that's fluff information. It's information we don't need. So it says that Jake's tank has 25 gallons of water in it, plus the fact he's filling it at a rate of 10 gallons per minute. Now we want the tanks to be filled or to have the same volume. So we know that we're going to have the same variable because we're going to set them equal to each other. Carla's tank already started with 125 gallons, but hers is only being filled up at 5 gallons per minute. So here are my two equations. So now we're going to set them equal to each other since we're talking about the same. So I have 25 plus 10m equals 125 plus 5m. And now we start solving for m. So we minus 5m. So I have 25 plus 5m is equal to 125. We're now trying to isolate our m here, so we're going to subtract 25. So 5m equals 100. Divide by 5, which means the number of minutes is 20. To find out how many gallons the tank is holding at that point, we plug 20 back in. So T equals 25 plus 10 times 20. So I have 25 plus 200, which is 225 gallons. Now, technically, if you were to look at this problem, it's a poorly created problem because Jake's tank only holds 200 gallons, so the 225 gallons would be overfilling it. But that is the correct answer for this. Unfortunately, it just didn't work out the way it should have. Number 4, this question should look familiar to you. I believe it was on your first quiz in Module 9. We're looking for the solution to the graph shown below. The solution is where they intersect, and we just have to label that point, and that is the point of 2, 4. Number 5, here is another word problem. So we have Mr. Frankel who bought 6 tickets to a puppet show and spent $44. So we need to write one equation that is equal to 6 and one equation which is equal to 44. Well, the 6 is the number of tickets, and he bought children's tickets and adult tickets. So I'm going to write A plus C equals 6. You could also write C plus A. Then to add up to $44, we know that the adult tickets cost $10. Children's tickets cost $2. And there are my two equations. So now we need to figure out how to solve this. You could solve it by either substitution or elimination. I have a feeling most students are going to choose elimination, so that's the route I'm going to go. The easiest way to eliminate this, I think, would be to make the C's match since they're smaller. You could make the A's match, and that would be fine. So I'm going to multiply the top equation by -2 so that the C's become opposites. Then I'm just going to write it below. So I have -2a minus 2c equals -12. Add them together. 10a plus -2a is 8a. The c's cancel. 44 plus -12 is 32. We're going to divide this by 8. So there were 4 adult tickets. So logically you could figure this out just so you understand where it came from. So I'm going to plug it back into the top equation. 4 plus c equals 6. So if we have 4 adult tickets and it has to add up to 6, that means we bought 2 children's tickets. Here we have a system of inequalities. and we're asked to represent the graph shown below. The biggest thing to note is that here are the overlapping solutions. So we have to base our inequality signs off of this shading. So I'm going to start with this line here. And in order to label that line, I need to figure out the y-intercept and the slope. So the y-intercept, we're looking for where it crosses the y-axis. That's here, which is 2. Notice this graph does not go up by 1s, it goes up by 2s. So I know that b is 2. And now I need to find m. To find m, I'm going to take 2 points. I already have 1. Here's another good point that hits on the line. Well, the slope had to go down 2, and then it had to go over 3 to the right. So my slope is -2 over 3. Now, we did say that each box counts as 2, so if you wanted to, you could use that. So then you'd be going down 4, and then over 6 instead of 3, and that would still simplify to 2/3. So my first inequality, I know the right side is -2/3 x plus 2, and I have to figure out which inequality symbol is put here. Now first of all, the line is solid, so I know it has to have the equal to part. So now I have to figure out greater than or less than. Well, I look at where it's shaded, and it's shaded above the line, so that does mean greater than. So there's my first inequality. My second inequality is this line here. So first thing is I'm going to find the y-intercept, which is at -4. And then locate another point. Crosses right here. This is positive slope because I'm going up 1 and over 1, which is just 1. So right now I know I have a y, a 1x or just x, and then -4. And I have to figure out which inequality sign. It's once again a solid line, so it has the equal to part. Now I look at how the line is being shaded. It is shaded above, so once again we have another greater than. So there are my 2 inequalities. Here we have a catering service that's organizing a formal dinner for 280 people. You have a hall that has 2 kinds of tables, one that seats 4, one that seats 10, and the hall can contain a total of 52 tables. Well, I'm going to call the tables that seat 4 people X, and the ones that seat 10 Y. Well, I know that between those 2 types of tables, they can only have 52. So X plus Y is less than or equal to 52. And now we have to make sure that they have enough space for 280 people. So the X table seat 4 people, the Y table seat 10, and we need it to be less than or equal to 280. So here are my 2 inequalities. I'm going to go ahead and solve both of these for y in order to graph it. So the first inequality, x plus y is less than or equal to 52. I'm going to subtract x. So y is less than or equal to -x plus 52. We can only use the right quadrant, the top right quadrant, quadrant 1 for this, because you can't have negative values. So I'm going to ignore the other 3 quadrants. So I'm ignoring this one, and this one, and just concentrating on that. I'm going to go ahead and solve the other inequalities so I know how far up my graph needs to go. So now I have 4x plus 10y is less than or equal to 280. Subtract 4x. y is less than or equal to -4x plus 280. Divide by 10. y is less than or equal to negative 2/5 when I simplify that fraction, plus 28. So I have 28 and 52 that I need on my graph. So I'm going to go up by 5s, I believe. Let me see here. So if I go up by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Just a little bit short, and that is important. 28 is divisible by 7 and by 4. 4s won't cut it, so I'm going to go up by 7s. So 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. And then to keep it consistent, I'm also going to go by 7s across. Okay. The first one, we have a starting point of 52. And make that one red. So 52 is going to be around here. And our graph, our slope is negative x, so down 1 over 1. So when I do this, even though they're going up by 7s, as long as I'm consistent, I can just simply go down 1 to the right 1, down 1 to the right 1. This was a solid line because it did have the equal to part. So I'm going to go ahead and connect this. Remember, we only need it to go to quadrant 1. So there's the first one. My second inequality is negative 2/5 x plus 28. Do this one in blue. So I'm going to go to 28. And then I'm going to go down 2 and over 5. Okay, and connect this one. Now I do have to admit that I forgot to shade the red line, so I'm going to go take care of that now. It is less than or equal to it, so I have to shade below it. So that's all of this. The blue line is also less than or equal to it. So that's all of this. And again, you should be shading yours in so it should look a little bit nicer than this. So the region that we're interested in is this region right here. The question said to write and graph that can be used to determine the possible combinations. So we wrote it and we graphed it. One other thing I'm going to do is go ahead and let's list some combinations just so we understand the region I'm looking at. You could do 7 of your 4-seat tables. And let's see here, on the 7 line, you could go all the way up to like 21 10-seaters is one combination. And obviously there's many more that you could list there, but that's just one to keep in mind. So now we have a system of inequalities that the equation inequality is already written for us to graph. So this will be a little bit quicker. So the first one, y is less than or equal to negative 2x minus 1. Well, my y-intercept is the negative 1. And the slope for this one is negative 2. So that means we're going to go down 2 over 1. Down 2 over 1, before I connect them. Let's check. It's a solid line. Make sure you're using your straight edge here. Okay, to shade this one, let's look if it's above or below. It's below. So I'm shading this region down here. Second inequality is y is less than 1. Whenever there's just a y, that means it's a horizontal line. So I go to 1 on the y. It does not have the equal to, so this one's a dotted line. Now I need to look where I'm shading. It says less than it, so I need to shade below. So the region where the solutions would come from is this region right here. Here we have a system of equations to solve by graphing. The equations are not in y equals form, so we're going to have to do that first. So let's start with the top one. 3x plus 3y equals -9. So I'm going to subtract 3x. So 3y equals -3x minus 9. To solve for y, we then need to divide by 3. So y equals -x, 3 divided by 3 is 1, minus 3. So my y-intercept is at -3. My slope was -x, so that means down 1 and to the right 1. And it's an equation, so I can just go ahead and connect the points. I don't need to worry about it being solid or dotted. Let me try this line again because this is going to matter if it's off. I'm going to go ahead and make some more dots so that my line looks nice and complete. Okay. Second equation, 3x plus 2y equals -4. To solve for y, we need to subtract 3x. So 2y equals -3x minus 4, divided all by 2. So y equals -3/2 x minus 2. So my y-intercept is -2. And my slope is to go down 3 and to the right 2. Nice thing is, even with my line looking sloppy, the point's connected. So the solution is right here, which is the point 2, -5. There's the solution by graphing. Number 10, we have another word problem. Zara spent $29.75 on 15 party favors. So I know one equation has to equal 15. One equation has to equal $29.75. She invited both boys and girls to her party. So G plus B equals 15, or B plus G. And the boys' party favors were $1.75, the girls were $2.25. So this is one to solve by elimination. So I'm going to multiply the top one. You could either multiply by negative 2.25 or negative 1.75. I'm going to go the smaller number, negative 1.75. So I'm going to get negative 1.75G, negative 1.75B, and negative 26.25. Add these together now, and I have 0.5G. The B's cancel. Equals 3.5 or 3.50. Divide by 0.5. G equals 7. So that means 7 girls plus how many boys equaled 15. So that means 8 boys were at the party as well. Number 11 has an infinite number of answers, just like it has an infinite number of solutions. To write an equation that would make this system have an infinite number means that everything has to cancel out, so that 0 equals 0. So you could do something like 2y equals 2x plus 4, because if you multiplied this equation by negative 2, everything would cancel out with that. Or you could make the equation negative, so negative 2y equals negative 2x minus 4, and that would automatically cancel, multiplying the top one by 2. You could do a multiple of 3, or make them all negative. And all of those would have an infinite number because they would all end up being the same equation, which means they would cancel out. Number 12 is just asking us to solve this. If you look at the two equations, you'll know they're both equal to y, which means we're going to set the equations equal to each other to solve. So 3x minus 1 equals 5x minus 3. Start solving for x. I'm going to subtract 3x. So negative 1 equals 2x minus 3. Now I need to add 3. Negative 1 plus 3 is 2. Solve for x, we divide both by 2. So x equals 1. Well, if I know x, I now need to find y. You can plug it into either equation. I'm going to go ahead and choose the first one. So y equals 3 times x, which is 3 times 1, minus 1. So y equals 3 minus 1, which is 2. So my solution would be 1, 2. Number 13 asks us to solve the system of equations again. This one, the x's and y's are lined up. I already have a pair of opposites, so I can go ahead and just simply add these together. So my x's cancel. Negative y plus negative y is negative 2y. Be careful on that, don't let it trick you. 10 plus 12 is 22. Divide by negative 2. So y is negative 11. We still need to go back and find x. The top one has less negatives, so I'm going to choose that one. So 2x minus negative 11 equals 10. Well, the negative 11 and minus becomes plus. So I now really have 2x plus 11 equals 10. So I'm going to subtract 11. 2x equals negative 1. Divide by 2. X equals negative 1/2. So my solution is -1/2, comma, -11. We are still solving here. This one again, the x's and y's are lined up, so this looks like an elimination problem. You could make this substitution and really solve for any variable because they're all pretty much by themselves. I don't have any opposites to start, so I'm going to change the signs on the second equation, or multiply by -1, it's the same thing. So -x, -y, -9. And when I add these together, my x's cancel, my y's cancel, which means 0 here. -1 plus -9 is -10. Since my variables cancel, that either means no solution or infinitely many. This is a false statement, so it means no solution. Which means on a graph, these would be two parallel lines that never cross. Next system to solve here, looking at how it's set up, we have a variable that's all by itself. So this is set up for a substitution problem. So I'm going to replace the y in the second equation with what this y is equal to, x minus 1. So I have x minus, and then in parentheses, x minus 1, and that's equal to 7. These parentheses were really important because of this negative out here, because I'm going to have to distribute it. So I have x minus x plus 1 equals 7. Well, my x's cancel, so I'm left with 1 equals 7. So x's cancel, that means I either have infinitely many or no solution. I once again have a false statement, so that means no solution. Number 16, this system of equations, we have an x that's all by itself, so that means we're going to use substitution here. So I'm going to substitute in the bottom x for 2y minus 6. So I have 2y equals 2, and then in parentheses what x is, 2y minus 6, and then plus 3. Left side stays 2y. Distribute the 2 on the right, so I now have 4y minus 12 plus 3. So 2y is equal to 4y. Combine the -12 plus 3, and that makes -9. Since the 2y is by itself here, I'm going to move the 4y over. I know we tend to move the opposite one over, the smaller one, but this one makes it easier since the 2y is already by itself on the left. 2y minus 4y is -2y equals -9. Divide by -2. So y is equal to 9/2, or I know some of you will go ahead and change it to 4.5. Plugging that back in, I'm going to use the top equation to solve for x. So x is equal to 2 times 9 over 2, or times 4.5, minus 6. Here the 2's are going to cancel, so I simply have x equals 9 over 1, or just 9 minus 6. So x equals 3. So my ordered pair would be 3, 9/2, or 4.5. Last problem here. We have the system of equations to solve again. This one, x's and y's are on the left side, all lined up, so we're looking at elimination. I do have a pair of opposites, so I can simply start by adding these two equations together. 2x plus 3x is 5x. My y's cross out. 4 plus 1 is 5. Divide by 5 on both sides. X equals 1. So now I need to find y. The top one equation is all positive, so I'm going to plug it back into there. So 2 times 1 plus 5y is equal to 4. 2 times 1 is 2. Subtract 2. 5y is equal to 2. Divide by 5. Y is equal to 2/5. Or 0.4, but you don't have to replace 2/5 back in, so it's just easier to leave it. So my solution would be 1, 2/5. And that is the end for the Module 9 review for your test.